Hello everyone, welcome to Tech with Machines. Welcome to another day of learning and hope you are having a great day. Our today's topic is Python threads and processes. We're going to learn about what these concepts mean and we will follow this with a coding example. This is our first video in concurrent programming series and we will also have the concepts related to global interpreter lock in Python, asynchronous programming, what does await and async really mean in Python, what is multiprocessing and multithreading in Python. So today's concentration will be more on threads and processes. So let's begin with the fundamental definition of each one of them and how they contribute to concurrent programming. Let's start with what a process really means. I will try to give a real life example, and it's a very simple and straightforward example. It's your web browser which is currently running on your computer or on your laptop. So when you launch a web browser, when you open it, it actually starts as a separate process. So operating system generally create a new process for the web browser application, and this process has its own memory, has its own resources, including CPU and files, and it allows this process to run independently. Generally, each process remains isolated from other processes on your computer, and which means that if one of the tabs of my web browser crashes, it will not affect or impact other tabs which I might have opened or other browsers with which I might be dealing. So generally, the operating system scheduler manages the allocation, CPU time allocation to different processes, including the web browser which might be running on your computer. This is ensuring that there is a fair usage of CPU processes, resources among running processes. Generally, the processes communicate with each other or with external services through IPC mechanisms like sockets, pipes, or shared memory. For example, when you download a file using the web browser, the browser process communicates with the operating system's file system process, which might be the Finder on your Mac or Windows Explorer, using IPC to handle the file download and storage. There is multitasking support in processes by allowing you to open multiple, for example, allowing you to open multiple tabs or windows simultaneously. So each tab or window operates as a separate thread within the web browser process, providing concurrency and responsiveness. So process is generally an instance of a running program which is isolated from other processes and has its own memory, has its own resource, including the CPU time. Whereas thread is the smallest execution unit within a single process which shares the memory space, right? So processes are generally costly because they need objects to be serialized and they actually communicate with each other and pass raw bytes from one process to another, whereas threads are lighter and they can work with less resources comparatively, and they offer lightweight concurrency within a process. So it generally depends that what choice between processes and threads on factors like resource management, communication needs, scalability requirements, right? So that's what is the key difference, or that's what each one of them means in concurrent programming, and how they work and how we can actually create a Python multi-threading application or a Python multi-processing application. We'll see in a bit with the coding example. So today's hands-on is going to be about writing a simple program that blocks for 3 seconds while showing animating characters in terminal to let the user know that the program is thinking and not stalled. It is one of the examples being given in one of the books named Fluent Python by Luciano Ramalho. It's a great book and it's very useful if you want to learn Python and be more fluent in deeper concepts. So let's go through those examples and see how we can implement them using Python package. Let's go through our first example, which we are naming as spinner thread, and we are going to use Python thread to implement this. I have detailed out the basic skeleton, which is having a spin function, which is going to be our target function, which will run in a separate thread. We are also going to use the slow function, which is actually causing the particular which will be actually called by the main thread, and will actually call the sleep to block the main thread, right? And then the supervisor, which will actually spin the separate thread, and finally the main, which will call and get the result of slow. So let's start with spin first. Our main objective is to let user know that the particular process or program is thinking instead of getting stalled, and after 3 seconds we want to print the output of the slow function, right? So in spin, what we are gonna do is we are gonna use itertools dot cycle to create an infinite loop and read the characters which will actually be shown in the terminal, and we'll use the carriage return ASCII control character, which will basically move the cursor back to start of the line, right? To actually imitate the text mode animation, correct? So that's a trick for text mode animation in general. So let's try to create this cycle, infinite loop using itertools.cycle. So we are going to use the carriage ASCII control character, and we will have the forward slash, the pipe, and the backward slash as a combination along with hyphen to show those characters to the user, saying that the program is actually thinking. So we'll use a status variable with a formatted string, and again we'll use a carriage ASCII control character and print the character as well as the message separated by the space. Message is generally the message which we are planning to print to the user, right? Let me correct the spelling of status here. Perfect. And now we are going to print the status, and we'll use the end parameter here to have the last space after we print the status, and we'll say flush equal to, I'll also use the flush parameter saying flush equal to true. We are using the instance of threading.event, which actually is a simple object to synchronize threads. So we are going to do event.wait for like 0.1 second with 0.1 second timeout, and if another thread sets an event, then this method will return true, otherwise it will return, and if the time out elapses, which is like 0.1 second, then it will return false. So if you want that the spin should go faster, then you can actually use a smaller timeout. So we'll say done.wait 0.1 here in this case, and actually break the loop here in this case, right? And then we will also have some follow blanks as a variable, and let's see, it's a space and it's actually the same as our status length, and we finally print this also. So print, and we do a formatted string and say blanks, and again we return back here the carriage ASCII control character, and also use the end in this case, right? So this is all about the spin function. So we are going to really do this. Sorry, here I have done a mistake. I have to use slash, so I'll have to clean this. So this is all about our spin function or target thread function. Now in the slow one, we are gonna basically cause the thread to block or sleep for 3 seconds. We'll use the time package and use time.sleep for 3 seconds and just return the random variable. Let's say it's 42 as a random variable. Now in supervisor, what we are going to do is we are going to first create the wait object, which is threading.event instance. So which is this, which will allow us to check whether the thread has to wait or it can actually come out. So we'll do spinner equal to, so here we are going to use the thread object. So we'll and its target method is really the spin function, and arguments what we are passing here is one that the program is thinking and the event object. So let's do that. We will actually do this, and we'll also pass the threading.event instance, which is done as an argument. Now let's print this as an object as well. So we are going to print the spinner object with the formatted string. So we will actually do this, and finally we'll start the thread, spinner.start, and we will get the result. Okay, let's first fix this. So we have created a thread and passing two variables. Also we have printed the spinner object, we started the thread, and our result is nothing but the output of slow function. And then we are going to say done.set. Basically the thread is, it's started with another thread, and then do the spinner dot join and return the result, right? So basically what we are doing is we're waiting until the spinner thread finishes by doing the join, and then finally returning the result. And in the main thread we are gonna call the supervisor function. We'll run it. I have written separate main and supervisor functions so that we can understand it better. So here we will actually call this supervisor, which will be called by, which will return really the result of slow, and we will print the final answer as formatted string. Answer is what we will be printing, which will be generally the result, right? So let's now run this and see what happens. So a usual way of running the main function, it will be name main and return the main function. So I'm going to run in the terminal and we'll say Python, and the name is spinner thread.py. So let's run this. Spinner, I think I have done triple n instead of 1. So as you can see, it's actually spinning, and it will spin for 3 seconds, and finally it's giving us the answer, which is 42. So this is how you can create a simple program using Python threads. Now we will start with another example using the multiprocessing process in Python. So now we are going to talk about multiprocessing package, which actually supports running concurrent tasks in separate Python processes instead of threads. So when we will create a process instance, a whole new Python interpreter is started as a child process in the background, which is unlike how we do thread. So in this we will actually get introduced with the multiprocessing package, and how it is very much similar to how the threading API is being written in Python. So it's very easy to convert a program which is using thread into a process, right? So we'll use, I had created one more file, but what we are going to do is we're going to use the same example and change little bits of pieces here to convert it into a program which is using the multiprocessing process object. So what we'll do now here is instead of using the threading dot thread, we'll use multiprocessing's process, and also the event instance will be from the multi-threading process and not from multiprocessing, not from the threading. So this will actually become process, and we will run this. Let's try to run this and see if it runs properly, and see, as you can see, it has run properly. Also, one more thing is that here the key difference is it's pretty much same what we actually printed in the first one, but only difference is that we are using process which is pretty much similar in terms of the usage to thread. So that's the beauty of Python, where you can use thread and process in a much similar way and understand it better, right? One difference which you will see is that in threading, in the example where we use threading, the event was actually an instance, or it was actually a class, right? But in this case, it's actually not a class, it's a function. As you can see here, it's a function instead of a class, and it returns the synchronize dot event instance. Okay, so this is how multiprocessing is being used, and in the previous example, that's how the thread is being used, right? So basic syntax is pretty much same, but of course their implementations are different. Here it's a child process instead of a separate thread. And multiprocessing also has a much larger API to handle the complexity of multi-process programming than the threads in Python. So that's it. That's all about today's topic. We'll go through the similar example by using coroutines in Python, but that's pretty much about today and today's concept. So I hope you liked the video, and if you did, please remember to subscribe. It helps me to it motivates me to create more videos on these concepts, and let's learn together. Thank you.